Hi there, everybody, and welcome. Welcome to a spring-like, or I should say almost spring-like, Stockholm here in Sweden. And welcome to Ericsson Headquarters, where we are broadcasting from to you live today. So 5G, I should say like this. My name is Joachim Bildt, and I'm heading up product marketing here at Networks at my usual work. But right now, I'm the guide for you in this session, and it's an honor to be here. And this is what I do in my day job. I try to make our portfolio, Ericsson Radio System, shine and come through all the way to you. So glad that you're with us. To start off with, 5G is off actually to a great start. It's the fastest growing mobile network technology to date, with over 120 live networks around the globe, out of which Ericsson powers 79 of them. That's just astounding. 2 weeks ago, Gartner announced their 5G infrastructure Magic Quadrant, and they announced Ericsson as a leader, and we're really proud of that announcement. But last week, and the most exciting news last week, was our launch, the announcement of additions to our Ericsson radio system. So we have here today a set of new mid-band Massive MIMO radios and RAN compute products, all powered by the phenomenal Ericsson Silicon. So if you watched the intro movie, I know it was fairly brief, but if you watched it carefully, you saw Farid here, a colleague of mine, holding up the new Air 6419 product, and I have it here with me today. We'll talk much more about it in a short while. But we want to engage with you on this social media channel. We want to engage with you and have you share a like or a heart whenever you hear something great. We want you to share this link and invite friends and colleagues to view this with us. We also want you to ask questions. So in the chat box, please keep on adding questions and say where you are from, because we would like to know. We will soon ask you questions as well. So we will ask you questions, 2 of them actually, on what we will talk about today. And there's an online tool for that. So go to menti.com using your smartphone or tablet or laptop, whatever you can find to go on to menti.com. And type in the code 67728. And by that, I want to challenge you with the first question. The launch that we had last week was all about accelerating 5G midband. So my question to you is, what is midband? What spectrum is midband? We'll come back to the result in a short while, but I hope you found that question on menti.com using the code on the screen here next to me. All right, it's time to meet the first of our experts in this broadcast. And I'd like to welcome here to talk about the great 5G technologies and products that we have ahead. So I want to welcome Sibel Tombas, who's heading up our high band, mid band, and Massive MIMO portfolio here at Ericsson. Welcome.
Thank you, Joachim.
So 5G is live, and many of us see this little 5G icon at the top corner of our smartphone. So what is really meant with us accelerating 5G?
Correct, Joachim. So 5G is live, and it has been the fastest growing technology we have ever seen. But when we look at the numbers, as of today, there are only 19% of the world population is under 5G coverage. And when we look at the broader perspective, up to 50% of the world population is still waiting for a reliable broadband connectivity. And considering how connectivity is important for our lives, for our society, for economic growth, especially after COVID, my dream with 5G is to ensure that high-quality connectivity doesn't seem like a privilege anymore and is accessed by anyone, anywhere, anytime. And that's the reason we say we need to accelerate 5G, and we need to act now.
So what with 5G really excites you?
I mean, there are a lot of cool applications and use cases under discussion, but I think the one that really excites me a lot in the consumer space with all these cool AR and VR applications. But I think even more exciting is the things that we don't know yet, because we don't know how all these great minds in the world, what kind of innovative solutions that they are going to bring in our 5G innovative portfolio. And I want to understand how they want to ease our life, how they will change how we work, how we collaborate, how we socialize, and even more importantly, what kind of solutions that they will bring that will change one of the biggest problems that we face today with climate change, with economic growth, and also, of course, access to education for all the children across the world. So there are a lot of exciting areas, and I'm very excited that 5G will be key to really achieve and solve most of these problems, I'm sure.
So coming back to the launch, accelerate 5G midband. So really, can you explain, and also sort of the question that we alluded to the audience here, can you explain what midband is?
Of course. So in 5G, compared to the previous generation, we're actually creating a multi-layer network with low bands, mid bands, and high bands. You almost can see as like a 3-layer wedding cake. In the bottom of this wedding cake, we have the low bands. And with the low bands, and these are the bands that we actually used in the previous generations, like 1800, 900 megahertz FTD bands. And these are great with FTD, and now we are also using for 5G, utilizing our Ericsson spectrum sharing solution. Then we have the high band, and these are the bands also called millimeter wave, like 28, 39 gigahertz spectrum. And these are also the first time actually we are going to use for mobile communication. So it's quite exciting. And you can almost see also the icing on the cake. But then we have the mid bands, just in the middle, that is sub 6 gigahertz, around 3.5 gigahertz region, is now becoming globally available for 5G.
And I believe that was the answer, ladies and gentlemen, the correct answer to the Menti question. So let's bring up the Menti question here and see what we have.
Ooh.
Great results. So we have over 150 people answering, and the right answer is what Sibel just said, the 3.5. So the 700 and 2.1 is considered the low bands,
yes,
the base layer of the cake. 28 gigahertz is the top, the icing of the cake, and then the 3.5 is then the mid band. So what is so attractive with this mid-band spectrum, Sibel?
Yes. So the access spectrum, first of all, gives us bandwidth. And bandwidth gives us higher capacity and higher user experience, which is exactly what we need to cater this increased demand for 5G. If I just look at some numbers, if I just give you some examples, by 2026, we expect that there will be 3.5 billion 5G subscriptions in the world. And the mobile traffic will increase more than 4 times compared to what we have today. And 50% of us that are using smartphones today will be using AR, VR glasses and with all these cool applications on top. It means that we need to create a high-performing network with instant response time and with a lot of capacity to cater this demand. And mid-band spectrum will be key to achieve that.
So it seems like a precious bonus here on the mid-band spectrum, for sure. So in this part, I mean, the higher up you go in terms of spectrum, as I understand it, the shorter the reach as well. So how do we work with that in terms of the midband?
Correct. That's actually one of the biggest challenges to go to the higher spectrum. We have a lot of bandwidth, which is great, but on the other hand, we are losing the propagation conditions and the coverage shrinks. But luckily, we have solutions to that. The first solution is to leverage low band. And that's the reason we need this low band in the bottom of the cake with Ericsson spectrum sharing. By using the low band and carrier aggregation, we can boost the coverage of mid-band. And the second solution is Massive MIMO technologies. Massive MIMO is not only important for increasing the spectral efficiency of mid-bands, but it's also key to boost the signal where it should be strong and accordingly overcome the challenges of 3.5 gigahertz with the coverage. So we solve that with Massive MIMO.
So it seems like, and here we got the picture again, I mean, midband seems to be really the key thing here. And you're talking about Massive MIMO now. And Massive MIMO is one of my favorite technologies as well, right? So I don't know if we can get it up on the screen here, but it's time for the next Menti question. So everyone, please go to menti.com and enter the code 67728. And the question for you is basically, what does MIMO mean in Massive MIMO? So think about it. What is MIMO in Massive MIMO? We'll come back to that in a short while. But Sibel, first, let's demystify what Massive MIMO is, please.
Yes. So Massive MIMO has 2 key components. And the first being, of course, the Massive MIMO radios that we just carried in the beginning. Yeah. So Massive MIMO radios is an integrated hardware unit that has hundreds of antenna elements inside. And this is key because it effectively does that increase the area where we transmit and receive signal, so which means that it gives us a higher antenna gain, which is again key for coverage and overcoming the problem with midbands. And the second piece is the software. And that basically gives life to hardware. With the flexibility that is provided with this radio, with all these antenna elements, we create customized beams. In 4G, we had one white beam, it was static, and we just get the best out of it. But in Massive MIMO and with 5G, we cannot live with that. We need to ensure that every single user in the cell gets his own customized beam, and it also ensures that it needs to be reshaped every half millisecond, so that 5G experience is continuous there, regardless where the user is.
Half a millisecond.
Correct.
That's not much. So both hardware and software combined into one system, let's say, in that sense, right? It sounds like in order to do that half a millisecond level of computing, we need a lot of processing.
Correct. So again, these radios has hundreds of megahertz of bandwidth. And we also need to have hundreds of thousands of users in the cell. And at the same time, I need to ensure that I have customized beam that is optimum for all the users at the same time. And it requires, and that's why you can see Ericsson Massive MIMO as a real-time processing machine that is making millions of calculations every millisecond to ensure that everyone gets his own customized beam and is also reshaped regardless of how fast they move. And what will happen is that regardless of if you're at home watching or playing game, or if you're at the train going home with 3 km/100 per hour, you will get the best 5G experience everywhere under Massive MIMO coverage.
Very good summary, I say, about or what Massive MIMO is. Thank you, Isabel. For those of you who want to know more about Massive MIMO and the Massive MIMO systems and how we build high-performing Massive MIMO systems as well as radios in Ericsson, please go to ericsson.com/techunveil and you'll find more information there. A couple of blogs and a video episode where actually Sibel herself is explaining just this piece about this. All right, I think it's time for the second Menti question about what MIMO means in Massive MIMO. I think the audience is well trained here, so thank you so much. You're doing really, really well. Out of the 180 roughly people answering, only 12 of you had what I thought was my sort of homework at school: minimum input, maximum output. At least that's what I was hoping for. But most of you here had the right answer: multiple input, multiple outputs. So really well done. Really, really well done there. Okay, we have also talked to the principal analyst at Global Data, Ed Gubbins, on what he sees the value is in both midband and Massive MIMO for 5G.
I think midband spectrum is essential for 5G. There's been a lot of focus and attention on the high frequency spectrum, understandably because it's a lot of bandwidth up there. But those higher frequencies aren't going to cover the whole world, so you definitely need midband. And of course, there's low band spectrum as well, but I think we've all seen at this point stories in the press about how, people are saying, well, is the 5G experience really that much better than 4G? And that kind of sentiment can make it harder to monetize 5G rollouts. So midband is really that sweet spot in terms of giving you, more coverage than the high frequency spectrum, but more capacity than the low band spectrum. In some cases, we're talking about 100 megahertz of midband spectrum. That's a lot. For some operators, that's basically a doubling of their spectrum assets. So, it's not that surprising that we've seen so much attention and interest in these midband spectrum auctions, because I think operators understand that this midband spectrum is really key to monetizing their 5G networks. So it's great to have all this midband spectrum, but what you really want to do is make the most of that spectrum, and Massive MIMO helps with that. So instead of taking a scattershot approach, Massive MIMO has these larger antenna arrays and intelligence to actually target the users, to give the users the fullest benefit of the spectrum.
Thank you, Ed. Thank you, Ed, for that explanation. So both Sibel and Ed has talked about the importance of midband and Massive MIMO together. It's really, really good to hear. But then the question is, how do we deploy it? What do we use to make that come to life? What products do we actually use? And that's what we're really here to talk about today. So behind me, or next to me, is part of Ericsson Radio System, the products that make up a mobile network. We're going to talk about new mid-band Massive MIMO products as well as RAN compute products. And I'd like to introduce to you our next speaker or next guest, our next expert from heading up the product line of radio, David Hammarvall. Welcome.
Thank you very much, Joachim.
Great to have you with us. So let's start. Let's start on your favorite side, right? Your own portfolio here with the new Massive MIMO radios. So we've launched 3 ones, and I think we're going to go through them one by one. So the first one being maybe the sweet spot, or being the, I should say, the shining star in this portfolio is the 6419. Please tell us more.
So the Air 6419 is really our flagship product. It's very high performance, yet ultra low weight. So this is only 20 kilos, and that means that a single person can carry it to site. And Joachim, you already have first-hand experience. How did you think it went?
Really well. I tried it just a few minutes ago, and it was really, really light.
I can only concur. And if you look at the 6419, we have built 20 kilogram products before, and Massive MIMO products also. The real leap of innovation here is that we're able to do it for our highest performance Massive MIMO line. So this is an uncompromising performance product. It has the 64 transmitters, 64 receivers. It has 192 antenna elements to give that highest antenna gain. And it also comes with the highest class of output power. So it has a 320 watts of output power, and all of that in 20 kilos. And you can see how thin it is. It's substantially thinner. It's a huge improvement over previous generation. And you can just see it on the previous generation sitting next to it. So it's a huge improvement in size and weight.
So that's the Air 6419. And then I know the second product here has a little bit different characteristics, the Air 3258.
Yeah, so here is the 3258. And this product has been designed with love for Europe. So if you look at the European cityscape, it's mid to low-rise cities, and then 32 antenna branches is the perfect choice. But the right or signature aspect of this is actually the 400 megahertz of bandwidth. And that actually is a really great number because it means it spans the full European midband. And that provides the perfect flexibility for all of the European operators to manage those spectrum assets. So the most challenging spectrum situations can still be supported with this radio. So for example, you can have operators with spectrum at either end of that 400 megahertz. This radio will support it. Or you can have operators that are considering spectruming in a subsequent auction. Now they don't have to feel worried that the products they deploy will support the upcoming spectrum. Or even operators that want to share the same radio in a RAN sharing configuration. This is a perfect radio for that as well.
Sounds like a flexible product for Europe. And I loved I really liked, I should say, your love for Europe in the design here. The last but not least, the third family member, the Air 3219.
Yeah, so this is the 3219, which shares the same high power and high gain as the 6419, but with a 32 antenna branch configuration. And that gives the perfect trade-offs then for low and mid-rise cities, but also suburban and even rural deployments. So it hits that sweet spot between performance, coverage, and total cost of ownership.
Really good. And we see these 3 products being sort of the how we can deploy and accelerate 5G with mid-band Massive MIMO across a large portion of the network then going forward.
Absolutely. And my personal favorite is actually the improved energy efficiency. So in all of these, we actually reduce the power consumption with 20% over the previous generation.
So with these 3 products, for maximum performance and the maximum flexibility of spectrum, and then sort of the maximum coverage on the 3219, how can we reduce the size, reduce the weight, reduce the power consumption while still maintaining or even increasing the performance of these?
Well, of course, we have a secret sauce, and it's Ericsson silicon. So Ericsson Silicon is our system on a chip family that has been tailor-made for the RAN products. And it is really the Ericsson Silicon that is the key to us meeting the immense computational processing needed to drive one of these Massive MIMO radios. And Ericsson Silicon has been designed to boost the performance, improve energy efficiency, and drive innovation. So let's meet Ericsson Silicon.
A tasty, or a tasty sauce indeed, I must say. Ericsson Silicon, David, seems to be sort of foundational or even core to how we design our products.
Yeah, absolutely. And it's by designing these high performance and energy efficient custom silicon that we're able to build these small, lightweight radio products that are industry leading in performance.
It's so amazing how technology can transform things into this, or how that happens. I'm just amazed. In the video, in the Ericsson Silicon video that we just saw here, there's a description of the 4 families within Ericsson Silicon. Can you explain them a bit more in detail and what they are and how they relate to these products?
Absolutely. So you saw the RAN compute line that is really tailored to run the full stack of the RAN application from layer 1, layer 2, layer 3. And it sits at the very heart of our RAN compute portfolio. And you also saw the transport. So the transport now comes with packetized front haul that also includes layer 1 processing. So there we can also take advantage of our system on a chip to make that really efficient. And then we had the layer 1 beamforming, and we had the digital front end. And it's those 2 system on a chips that goes into our Massive MIMO radios. And taking the first one, the layer 1 and beamforming system on a chip, that is really what allows us to drive all of that signal processing for ultra-precise beamforming, but also enable us to implement the Ericsson superior architecture, where we can have the uplink booster and the full uplink receiver implemented directly into our radios. And it's the digital front-end system on a chip that actually ensures that we get an extremely pure and linear signal that supports high performance coming out of our radios. And it's also that ensures that we can drive our power amplifiers in the most power efficient way. And of course, standing next to the AIR3258, the signature feature of this chip is also the support of the 400 megahertz of bandwidth. So we can support that in our power amplifiers and a really linear and nice signal across that 400 megahertz.
Amazing how the Ericsson Silicon is really sort of at the heart of these products. And we'll come back to the Massive MIMO products a little bit later. But I thought of, you were also saying or talking about one of these families of Ericsson Silicon being the RAN compute family then. And we also launched new products in this range. Can you elaborate a bit more?
Yeah, let's talk about RAN compute.
Please.
So we launched our baseband in 2015. Already then supporting multi-standard 2G, 3G, 4G, and 5G upgradable, and Ericsson spectrum sharing. So we've been doing this for some time. But a lot of things has happened in the last 5 years. Back then, it was predominantly distributed type of network deployments. Now we need to cater for much more diverse deployments like centralized RAN, we need cloud or virtualized RAN, we have outdoor and indoor deployments, and of course we need to support our great Massive MIMO products. So now we have diversified also our baseband portfolio or RAN compute portfolio.
Can you show us a bit?
Absolutely. So here we have a first instance, and this is the radio processor. And the radio processor is really designed for high capacity 4G, 5G use cases. And it's sitting right next to the radio rail mounted outdoors. So this is ideal for a distributed type of network deployment. But of course, we have more elements in our RAN compute portfolio. So we also have a full cabinet-based portfolio. And here we also have the RAN processor. And the RAN processor has that same high capacity for 4G, 5G application, including driving Massive MIMO. So here you can see the 6651 RAN processor. And that is also ideal for building C-RAN type of applications. But of course, we're not deserting the baseband line. So the multi-standard baseband supporting 2G, 3G, 4G, 5G, Ericsson spectrum sharing, and narrowband IoT all in one unit. Also get the new instance in the radio or baseband 6631. So this gives us a complete range of baseband offering for all of our main product lines and also allows all that flexibility in the site deployments.
Exactly. It sounds like it's a really wide range of products to fit into all types of site deployments. Such a great lineup, I must say. David, what's the value then of the RAN compute silicon, or I should say the Ericsson silicon inside the RAN compute portfolio?
Yeah, so with the new silicon in these RAN computes, we're able to boost the throughput with 50%. But also we're doing that with a power consumption that is 30 to 60% lower than the industry benchmark.
So high performing, easy to deploy, energy efficient. I mean, it sounds really, really good. All in that same range of products. Really, really impressive.
Indeed. And at the heart of this is Ericsson Silicon, right?
Yes.
So Ericsson Silicon is what is enabling us to take down that power consumption throughout our main product lines. And if you look at the entire site, you have reduced power consumption in the radio and in the baseband and in the transport. And of course, it all adds up to a real instrumental power saving in that site. And if you lift the perspective a little bit, if you look network-wide, that is thousands of sites. And of course, all of this adds up to really instrumental improvement in power efficiency. And of course, that means lower costs for our service providers, but also much better sustainability footprint.
It's really, really interesting. I mean, when you mentioned, I mean, the scale of things here, right? The thousands of sites. I'm wondering sort of in a system, in a network, how we put all these things together. So, I mean, the Massive MIMO radios and the RAN compute portfolio that we just learned about, I mean, they form the Ericsson radio system. And I would like to bring Sibel back. Welcome back, Sibel.
Thank you, Joachim.
So what happens when we take all these great products that David just spoke about and we put them back into a system, into a network? What happens then?
Yeah, so when we take all these great products together, and that is when the magic happens. And the main reason is the tight hardware and software co-design. So at Ericsson, we don't design the hardware and software separately. We actually create end-to-end solution that optimize the entire network from antenna to radio to RAN compute and software, so that we can get the best performance with minimum energy consumption. And again, our secret sauce is our Ericsson Silicon. Now everyone knows. And that's really the foundation of everything. It gives us this immense capability of processing with minimum energy consumption. So we can bring innovation to all our portfolio. And in our Massive MIMO portfolio, again, the key to achieve that, as David said, we bring the beamforming algorithms and beamforming processing at the radio. And this was key for us to be able to have the real channel information instantly, so we can create these customized beams for every single user. And then in the software side, innovation is easy. We have all the real-time data, we have the huge processing power, then we bring this ultra-precise beamforming, we bring uplink booster, so we can get the best mid-band coverage and capacity at the same time. So overall, the products that we launch today, they are impressive on their own, but they become unbeatable when they're combined.
Unbeatable when combined. Thank you, Sibel. I must say that's an impressive lineup and impressive sort of when you combine things. Really good. Thank you, Sibel, for that. I bet you have a lot of questions, all of you who are watching. So please post them in the chat. We will come to the Q&A in just a little short while. But before, I also want to hear from Ed Gubbins again on what he thinks about our recent launch.
So Ericsson's really been on top of the Massive MIMO trend for a while, and the products that Ericsson is launching now come with some pretty important benefits like energy efficiency and lightweight designs to make sure that these products are easy to install and deploy. And a lot of these product benefits really come from the Ericsson in-house silicon, which you see really across the portfolio in products like the Air products, the antenna integrated radio products, which are really a superset of the Massive MIMO category, as well as the RAN compute solution. So, Ericsson's really making a strong case for using mid-band and Massive MIMO to really, optimize and monetize 5G networks.
Thank you so much, Ed, for those wise words. Thank you very much for that. All right, we're now into the Q&A, or we're just about to start the Q&A. So please keep on posting questions, and we'll bring them up with the experts, I should say. Sibel, I got a question for you first, and it comes from LinkedIn, from a lady named Virginia. Why isn't 5G now accessible to everybody?
So thank you, Virginia. It's a great question. It's exactly the same problem we are trying to solve here. So 5G as a technology is actually here. So we have all the components that is needed. But what we need to now as an industry to accelerate the deployments. And for that, with all the products that we launched today, are key for operators to have a speed deployments of all this new portfolio and spectrum to their network. So overall, technology is there. We just need to come together, accelerate the deployments, and bring this mid-band experience to all our networks everywhere.
Thank you. And then next question is from Sharif here, from LinkedIn. Are we talking standalone or non-standalone 5G, considering we need dynamic spectrum sharing?
So it's basically both. Our portfolio can handle non-standalone and standalone simultaneously. Depending on which devices we communicate to, we can adapt to that. But of course, our vision for 5G is to be able to have the standalone, because that is where we can handle multiple use cases with dynamic slicing. But again, with all the devices that are different, we can handle all these different use cases and NSA and NSA, and with all the bands at the same time. No problem.
Thank you. Sharif, hopefully you were happy with that answer. So thank you for asking. And keep asking questions, everybody. Maybe a bit more than product-centric kind of questions for you here, David. And even going to the core here, to the Ericsson Silicon. Is Ericsson Silicon new for Ericsson? And that comes from Sten on YouTube.
Thanks for the question, Sten. Actually, Ericsson has been doing custom silicon for 20 or so years. And we increased the investments dramatically in custom silicon 4 or 5 years ago and continue to increase our investments in this area. What is really new is that we're starting to talk about it. And the reason we're talking about it is because it's actually instrumental in understanding how we can build so great products. So it's becoming an increasingly dominantly important part of our products.
Thank you, David. And the next question comes from Gareth Owen at Counterpoint Research. And he is asking, what is the maximum channel bandwidth possible with the Air 6419?
So thanks, Gareth. For the 6419, that one is optimized for 200 megahertz channel bandwidth.
And then we've got another question here from James on LinkedIn. He says, cool improvements coming with the new products. Any feedback on integration improvement? What makes it easy to deploy?
So thanks a lot for that question as well. We have done a lot of improvements, both in serviceability, that we call it, where it's easier to hang the radios at site. But behind that low weight, which is really the signature feature for these new products in deployability, is a lot of added integration, of course driven by the Ericsson silicon, but also many other innovations within the radio with a tighter integration in that Massive MIMO radio.
So then we come into a bit of more focus on the ORAN and Open RAN relationship here, right? So from Ashwani Kumar on LinkedIn, he's asking, are Ericsson RAN products supporting Open RAN?
So thanks, Kumar. So Ericsson in general, we have launched Ericsson Cloud RAN that has a lot of interfaces open, complying to the ORAN specification. So we're big believers in driving that openness for artificial intelligence and automation and new use cases. These specific products are integrated products that has been co-designed between hardware and software. So these are designed with an integrated deployment in mind.
All good. And I think one of the questions that seems to be really popular here is obviously, and also again to you, David, around the products. When will these new products, or even the radios more specifically, be available from Nga over Facebook?
So there's a lot of service providers that are screaming for these products. So we will get them to market sooner rather than later. And the first one out will be shipping in volumes during this summer. So it's not that far out. And then we will, of course, bring in more frequency variants in the coming months after that.
And I got another question here, coming back to ORAN and coming back to custom silicon. And this time it's from Raquel on LinkedIn. Why is Ericsson talking about custom silicon when there is a lot of buzz around ORAN?
So thanks for the questions, Raquel. So customized silicon is really about making silicon that is tailor-made for a specific application. So in this case, we're making a customized silicon to support the processing need in the Massive MIMO RAN product. So it's really, in order to make a super competitive product, you need that custom silicon or customized silicon for that application, for these products. And that's why we're talking about it, because we have made really good investments and we're coming really ahead of the curve now with meeting the computational complexity of these Massive MIMO radios.
Okay. And then we have got Sharif and from LinkedIn. And Sharif is asking, what about indoor coverage of 5G? Will be as efficient as outdoor coverage and usage?
So thanks, Sharif. I think that there's multiple dimensions to this. So as you say, we have a higher frequency band here. It's 3.5 gigahertz typically. And it has less indoor or outdoor to in penetration. And that means that you need to synergize between multiple bands. However, the Massive MIMOs actually do circumvent that because you have a lot of beamforming opportunities to mitigate that effect. But really, this is a full network where everything fits together, from the low bands to the mid band, but also our indoor solutions. We have tailor-made indoor systems for 5G deployments as well.
Thank you. Let's take this now one step back and look sort of into your dreams and vision for the future here. Once this all is deployed, or as we are deploying it now with our customers, Sibel, what's your sort of dream use case here? What do you foresee that you want to do with this?
I mean, as I mentioned, actually, the one application I'm very excited about is all the AR, VR applications. And one key that I'm really waiting for is that allows us to have much more close relationship with our families. For example, yesterday it was my mother's birthday. We celebrated over FaceTime, but I'm really looking forward to much better virtual type, reality type application where I can actually almost be next to my mother to celebrate this big thing. So we don't, especially with COVID, that we don't actually miss this kind of day. So I'm really looking forward to all those applications related to virtual reality.
So somewhat of an enriched family sort of setting there, right?
Exactly.
Sounds really good. David, what about you? What are you envisioning, or what do you see?
I think all of these like intelligent transportation systems I find really cool, like remote controlled drones doing transportation and shipping, last mile deliveries, for instance. I think that is super cool application, but also aiding autonomous driving, I think will have a lot of really good impact to the society.
Wow, really cool, I must say. Thank you so much, both of you, for sharing that personal touch of what you foresee in the future. To all of you watching, thank you for asking all these questions, and thank you for engaging with us and liking and sharing and caring for us as well. This has been a great session with you today. I know you've got more questions, and we hopefully get to them later on, but not unfortunately in this broadcast. So if you're curious, knowing more about this broadcast for sure, but if you want to know more about our launch, go to ericsson.com/Massive MIMO, and you'll find more information there on our launch page, and also more information and links to Silicon, Tech Unveil, and so on and so forth. So thank you all for watching. Thank you, Sibel and David, for being part. And as we see this happening with these use cases and more coming to life by Ericsson and our industry accelerating 5G with midband. Thank you for watching. Hope to see you next time, but don't leave yet. You have a really nice video to watch now at the end. So thank you and goodbye from Stockholm. See you soon.